Hi, welcome to Unit 4, where we're going to talk about rational expressions. So getting started here, we're going to be doing Lesson 2 on rational expressions. We have 3 objectives. One is identifying rational expressions, 2 is creating equivalent rational expressions, and 3 is comparing rational expressions. So part 1, identifying rational expressions. We're going to be able to do that at the end of this first part. We're going to be able to determine where the expressions are undefined, and we're going to write the domain in set notation. So our keywords here are domain, polynomial, rational expressions, and undefined. So here's an example over here of what a rational expression looks like. Rational is a fraction where you have a polynomial over another polynomial. And of it, the denominator cannot equal 0. So some examples here, 3x plus 1 divided by 2x plus 3. Those are both polynomials. And 2x squared plus 3 divided by 5x plus 1. That's a polynomial divided by a polynomial. 1 divided by 3x plus 1 is also a polynomial divided by a polynomial. So let's take a look at those. Again, what is the definition of a polynomial? So a polynomial is an expression made up of variables, whole number exponents, and real number coefficients. So here's some examples of what a polynomial versus not a polynomial is. So if you have negative exponents, that's not a polynomial. If you have a square root of a variable, that is not a polynomial. If you divide by a variable, that's also not a polynomial. So feel free to take a screenshot of that so you'll know which is polynomial and which is not. What is a rational expression? So a rational expression is a fraction made of 2 polynomials. It has a numerator and a denominator. A rational expression is because it is the ratio of 2 polynomials. So it's very important that you understand that the denominator cannot be 0. It makes the expression undefined. So anything that if I would substitute in to the denominator, if it made it equal 0, then that would be excluded from the domain, and it would be making our expression equal 0 is undefined, and we can't have an undefined ratio or rational expression. So looking at these, can you determine which one is rational or not? So why would the not rational one, this first one here, why would it not be rational? What is the reason we say this is not rational? Because it has a square root there. It's not rational. And then the second one, well, it has like absolute value in there. It is not rational. So that is how you determine some rational versus not rational. Just another example for you. All right, let's talk a little bit more about the domain and undefined values. The domain are all the values that can represent the independent variable. Typically that is when you're talking about a graph, your independent variable are your x values. Your x values are your independent variables, where your y values on a graph are your dependent variables. How do we find the undefined values? Those are the values that need to be excluded from the domain because they make the denominator 0. So here we have an example, x plus 1 divided by x minus 4. You want to find the undefined values by setting the denominator equal to 0. So we've done that here. We've set x minus 4. This slash means not equal to 0. So if I moved the 4, I would add 4 to both sides. That would make x not equal to 4. So If I were to substitute 4 into the original rational expression, my denominator would equal 0 and would make it undefined. So my domain written in set notation needs to say it excludes the 4. Okay, so you have to exclude the number that would make it equal to 0. So your domain are all values of x, all real numbers, where x does not equal 4. And that's how you write it in set notation. So you're going to want to make sure that you know how to do that. So all we did here to find the number to exclude is to take the denominator, set it equal to 4, and solve for x. I'm sorry, set it equal to 0 and solve for x. So if I solve for x, I know that that number is going to be excluded and x cannot equal 4. So let's practice that. Determine if each is rational. If it is rational, state the domain. So here's number 1, 2, and 3. And I would love for you to pause this video and use your notes to determine if each of these expressions is rational. And then if it is rational, I want you to state the domain. All right, so let's go over your answers. Is number 1 rational? Yes. Number 1 is rational. Good. So I hope you said that that was rational. So this one is rational. And what would our domain be? So all values of x where x is not equal to what number? Do we need to exclude any numbers? Yes, we'd have to exclude. If I set my denominator equal to 0, I don't want it to equal to 0, so if I move the 3 over, my denominator cannot equal -3. So I'm going to finish my domain statement by excluding -3. If I plugged in -3 for x, that would make my denominator 0 and it would be undefined. All right. Number 2. Is number 2 rational? Well, it has a square root in it, so this is not rational. Not rational. Okay, so we don't need to state the domain there. Number 3. Is this rational? Yes, it is. So this is rational. So we know we have a domain of x values in the real number system, but we need to figure out what x does not equal so that we can complete our exclusion of the domain. So I need to set the denominator, which is x squared minus 9, to 0, and I need to solve for x. So I'm going to add 9 to both sides. Oops, let's see. Let's try this again. X squared does not equal positive 9. And then to get x by itself, I'm going to take the square root of both sides. So x cannot equal plus or minus 3. Because both -3 squared and positive 3 squared, both of those equal positive 9. So I need to know that I'm going to exclude both the positive and -3, because that would make my denominator 0. All right. I hope you got all those correct. Let's keep moving along and try our second objective. Now this objective in part 2, we're going to use factoring or division to create equivalent expressions. And we're going to determine undefined values. So you need to remember how to factor here and how to divide. Our keywords are polynomial, rational expressions, and quotient. All right. Take a look at our little graphic here. The divisor is usually in the bottom of the fraction, and your dividend is in the numerator. So if you wanted to make any fraction, let's just talk about numbers for starters. If we just wanted to talk about 16 over 3, I can write that as a division problem because the fraction bar represents division. So I would want to write 16 under the dividend and 3 outside. So the same is going to go when we have polynomials. Here we have a numerator and a denominator. So that whole denominator becomes your divisor, and the whole numerator becomes your dividend. All right, so here is examples of how to factor, to review your factoring. You might want to take a screenshot of this. You have binomials, which are 2 terms. They are factored by taking out the greatest common factors. You have trinomials, which are 3 terms. If there is a equals 1, you can just factor it into 2 binomials. But if a is greater than 1, you have to do your grouping method, and you still end up with 2 binomials at the end. And then we have 4 terms, which you're going to do again by the grouping method. So take a screenshot of that, and then I have one more, a difference of 2 squares. You want to make sure you know how to factor a difference of 2 squares. So for example, here you have x squared minus 49. That is a difference of 2 squares. X is squared and 49 is a perfect square because that's 7 times 7. So in reality, it's x squared minus 7 squared. That factors into x plus 7 times x minus 7. So the same thing inside, just one is plus or minus. Because if I wanted to redistribute this and multiply everything and then combine like terms, I would get back to where I started at x squared minus 49. The middle term would cancel out because of your plus or minus signs. So take a screenshot of that, and then let's use those to practice simplifying our rational expressions now. So using factoring to simplify. I'm going to do this one for us, and then I'm going to give you a chance to pause the camera and practice on your own on the next couple of problems. So x squared minus 4 divided by x squared plus 3x plus 2. I know that the top here is a difference of squares. So that is the difference of squares, and that is going to factor down to x plus 2 times x plus minus 2. Difference of squares. So 4 is the same thing as 2 squared. So I have x plus 2 and x minus 2. Now that's all divided by x squared plus 3x plus 2. My a value here equals 1. So I just need the factors of 2 that add up to 3. And I can go straight to my grouping here. What are the factors of 2? What multiplies to give me 2? That's going to be 2 and 1. And they add up to 3. So x plus 2 and x minus 1. So in order to simplify, I need to be able to cross out matching values. So x plus 2 and x plus 2 on the bottom, those can cancel out and leaves us with x minus 2 over x plus 1 as my simplified, that is my simplified rational expression. Now I need to write the domain where the x values are real numbers and x cannot equal. What are the values that would make that 0? Well, this denominator here, I have 2 factors. I have x plus 2 and x plus 1. So what would make those equal 0? That would be -1 and -2. So I cannot have x values of -1 and -2. So that is my domain. I have to exclude those values. All right, so we've done a problem together. Let's let you try this problem. And you're going to want to factor the numerator and factor the denominator. So pause this and work on this problem using your screenshots of how to factor. All right, so let's try this together. So I know my numerator has a value that's greater than 1. It's 2. So I need to multiply 2 times -3, which is -6. What are the factors of -6 that add up to 5? So we know we're going to have 2 and 3. So -2 times +3 is -6, but when I add those up, that is 1. What about +2 and -3? If I add those up, that's -1, so neither one of those worked. What about 1? Let's do -1 times +6, because that multiplies to give me -6. So that is going to equal 5 when I add it together. So those are my factors, -1 and -6, and I'm going to use those to break up my middle. Okay, so if I combine those like terms, 6x minus x would give me the 5x. So I have the first term is still in there and the last term is still in there, but I have just broken up my middle into 2 terms. So now I'm going to use my grouping method, and I'm going to factor out the greatest common factor of each group. The first one is 2x. So I'm dividing each term by 2x. That's going to give me x plus 3. And then I need to factor out a -1 of the second grouping, because that's all they have in common, and that's going to leave me with x plus 3 again. These are always going to match if you did that correctly. So now factor out that x plus 3, and what you have left is 2x minus 1. So that is your numerator. So your numerator has been factored to x plus 3 times 2x minus 1. So now your denominator, what you have in here, is now a difference of squares. So x squared minus 9, which is 3 squared. So you're going to have x plus 3 times x minus 3, your difference of squares. And then we can cross out this first one here because they match. And our final simplified expression, rational expression, is 2x minus 1 and x minus 3. What is our domain? X is going to be all real numbers, provided that x does not equal what can make the denominator 0, plus or minus 3. I don't know, my pen just kept stalling there, so I wrote a couple of them. So positive and -3 would make my domain undefined. Okay, so hopefully you got that one correct. You try one more. Go ahead and pause this camera again, pause the video again, and try this one. All right, let's see how you did. The numerator here is going to factor to 2 binomials, because my a is equal to 1. I can go straight into my factors of x and x. What are factors of 6 that add up to -5? That would be -2 times -3. all of that divided by the factors of -3 that add up to -2 would be -3 times +1. Okay? And that is what we have factors. So what can we cancel out? I've got 2 matching of x minus 3. So we're going to have x minus 2 over x plus 1, where my domain are the real values of x, provided that x does not equal, what's going to make these 0? What's going to make these 0? +3 and -1 would make those equal 0. All right, so that is our second objective. If you need more practice on this, you're going to get plenty of it during your IXL after this lesson. All right, so what if you can't factor? If you can't factor, you need to know how to do long division again. So we're going to do some long division. If you want to take a screenshot of this, you can, where you're going to divide the first term of the polynomial by the first term of the binomial. And then you're going to be multiplying by the term we found in the first step, and then you subtract the new binomial, and then you bring down the next term and you repeat those steps. You'll continue until you have no remainder. Okay, so these are no remainder problems, and your answer will be the polynomial that you get on the top. Okay, so here we have the first step was I have x cubed plus x squared minus 13x plus 3. I need to divide this first term, x cubed, by my first term here, which is x. So how many x's is it going to take to turn this into a cube? So since I have one x here, I need 2 more. So if I multiply x times x squared, I'm going to get x to the third, but I have to distribute it to my -3 also, so it's going to give me minus 3x squared. Now since I am subtracting here, I have to change the signs for everything. So this was minus, so that becomes plus now. So if I add those now, x squared minus x cubed is going to give you that 0. And then x squared plus 3x squared is going to give you 4x squared. So now you need to take the 4x squared and divide it by your x value again. So this is the blue line here. How do I turn x into 4x squared? Well, I multiply it by 4x. So 4x times x gives you 4x squared. 4x times -3 gives you -12x. Then I need to change the signs because I'm subtracting, so that makes my positives negative and my negatives positive. Subtracting 4x squared from 4x gives me 0. -13x plus 12x gives you -1x, and then you bring down your 3. All right, how do you turn positive x into -1x? Well, you multiply it by -1. So distributing -1 times x gives you -1x. -1 times -3 gives you +3. But since I'm changing the signs, I'm subtracting, I have to turn that negative into positive and my positive into negative. So now I would have 0 as my remainder. So that's the steps that you take to do long division. Make sure you take a screenshot of that if you need to. Let me clear out my writing on there. And use that as we go along and practice some problems with no remainder. All right, I'm going to do this problem for you, and then you can do the problems following. So x cubed is what I'm starting with, and that is going to go, remember, underneath, because if this was written as a fraction, this would be all over x plus 1, right? So the numerator becomes my dividend, which is x third plus 4x squared minus 2x minus 5. That's all under the box, and x plus 1 is my divisor. All right, so I'm going to change colors here so we can see these step by step. So the first thing that I need to divide is your x plus 1 is two terms, so my value is going to go above the second term. How do I turn x into x to the third? Well, I need an x squared to do that. So x squared times x is x to the third. X squared times 1 is just x squared. Now I need to subtract this, so that's going to turn all of these signs to their opposite sign. Okay, so I'm changing all of the signs. Now x third minus x third is 0. 4x squared minus 1x squared is going to leave me with 3x squared, and then I'm going to bring down the negative 2x. So my next color here, how do I turn x into 3x squared? Well, I multiply it by 3x. So 3x times x is 3x squared. 3x times 1 is 3x. I need to change my signs to subtract, and that's going to leave me with 0 minus 5x. I'm going to bring down my negative 5. And the final thing that I need to do now is, how do I turn x into negative 5x? Well, I multiply it by negative 5. So negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. But I need to subtract, so I'm changing the signs. So that is going to give me a 0 as my remainder. So my final answer here is x squared plus 3x minus 5, where my x does not equal negative 1, right? We can't equal negative 1 because that would make that equal 0. All right, so you take a look at that, and while you proceed to practice this problem, pause your camera. Okay, you can pause your video, not your camera, right? Well, hopefully you understood that. Let's work this problem, see how you did. I'm going to write it as a division problem. Okay, did everybody write it as the division problem like that? Okay, so how do I turn x into x third? Well, I got to multiply it by x squared. So I get x to the third minus 3x squared. I need to subtract this, so I'm changing the signs. So that's going to leave me with 2x squared. I'm going to bring down my 10x. How do I turn x into negative 2x squared? I'll multiply it by negative 2x. So 2x times x is negative 2x squared. Negative 2x times negative 3 is positive 6x. Since I'm subtracting, I need to change my signs here. So positive and negative becomes 0. 10 minus 6 becomes 4. And then I'm going to bring down my negative 12. How do I turn x into 4x? By multiplying it by 4. 4 times x is 4x. 4 times negative 3 is negative 12. I need to subtract that, so that changes the sign and gives me 0. So that's my answer, x squared minus 2x plus 4 where x does not equal 3. How'd you do? See where you went wrong if you made any errors here. I did it step by step there. See where you might have went wrong. But hopefully you got it all correct. I've got another one for you to try. So again, pause the video and try the next one. And let's see how you did. Okay. All right, the first thing we need to find is 2x to the third. So I need 2x squared to multiply by x to give me 2x to the third. And 2x squared times 5 is 10x squared. I need to subtract those, so I'm going to change my signs to subtraction there. That gives me 0 here and negative 3x squared here, bringing down my 14x, negative 14x. How do I turn x into negative 3x squared? Well, I need to multiply it by negative 3x. Negative 3x times x is negative 3x squared. Negative 3x times 5 is negative 15x. Need to change the signs to subtract. So that's going to leave me with just 1x, and then I'm going to bring down my 5. How do I turn x into x? By multiplying by 1. So plus 1 there. 1 times x is x, and 1 times 5 is 5. But I need to change the signs to subtract, so that gives me 0. So my final answer, 2x squared minus 3x plus 1, where x is not equal to negative 5. How'd you do on that one? Is it getting easier? Do you like factoring better, or do you like the division better? Well, let's just make a division just a little bit different. We're going to talk about remainders now. So all the steps are still the same. It's just when you get to the bottom and you don't have 0 left, you're going to have an answer that cannot be divided by an x, by a variable. So your final answer will not have a variable. And you're going to write that answer, sorry, move this out of the way, over your divisor here. So negative 17 divided by 2x plus 1 will be added to your answer that you got in the numerator. So this is what your answers are going to look like. Feel free to take a screenshot of that. Okay. Let's look at a problem here, and you want to pause this and do this problem. Again, we're going to just do the division just like we were doing. 2 times x to the third plus 4x squared plus 5x minus 1, all of that divided by x minus 3. So how do I turn x into 2x cubed? By multiplying it by 2x squared. 2x squared times x is 2x third. 2x squared times negative 3 is negative 6x squared. I need to change the signs to subtract them. So I have 10x squared. I want to bring down my 5x. How do I turn x into 10x squared? By multiplying it by 10x. 10x times x is 10x squared. 10x times negative 3 is negative 30x. I need to change my signs here. So that leaves me with 35x. I'm going to bring down my 1. How do I turn x into 35x? By multiplying it by 35. 35 times x is 35x, and 35 times negative 3 is negative, well, let's see, do that in my head, 105. I need to change the signs. That's going to leave me with 104. Okay, 104 there is my remainder, but how I write this is 2x squared plus 10x plus 35 plus 104 over your divisor of x minus 3. Now my x cannot equal positive 3. That's the only difference here, is when you have a remainder, you have to put it over the divisor and add it to your answer at the top. Let's try another one of those. Okay, so this one's a little different. I pointed out here that you notice that you're missing a cube and an x to the power of 1. When you're dividing, you have to make space for each of those descending orders, each of those terms, okay? You have to have a space for all of the terms. So what I'm going to write underneath is 2x to the 4th plus 0x to the 3rd plus 4x squared plus 0x minus 1. So 4, 3, 2, 1, and none there for your exponents. 4, 3, 2, 1, and none. Okay, you always have to have each of those represented. If you're starting with a 4, you have to have 3, 2, and 1. If you start with a 3, you have to have 2 and 1, and so on. Okay, so now that we've set up the problem, pause this video and go ahead and solve it. You will have a remainder here. All right, let's see how you did. How do I turn x into 2x to the 4th? Well, I multiply it by 2x to the 3rd, and that's going to give me 2x to the 4th plus 2x to the 3rd. I need to change my signs here to subtract, and I have 2x to the 3rd left, bringing down my 4x squared. How do I turn x into 4x squared? Then I multiply that by 4x times x. Oops, I already did something wrong there, didn't I? How do I turn x into negative 2x to the 3rd? That's what I need to do. So I need to multiply that by negative 2x squared. All right, negative 2x squared times x is negative 2x to the 3rd. And minus 2x squared times 1 is minus 2x squared. I need to change the signs. That's going to zero out and leave me with 6x squared plus 0x. Okay, how do I turn x into 6x squared? I'm going to multiply it by 6x. So that's going to give me 6x squared plus 6x. I need to change my signs. So that's going to leave me with negative 6x minus 1. I'm going to scroll this up a little bit. Whoops. Let's see if I can spin this page. Nope, that's not what I wanted to do. Go back. Okay. Just get my pen and keep going. I'll just move it over to the side. Okay, so negative 6x minus 1. How do I turn the x into negative 6x minus 1? By multiplying it by negative 6. So I have negative 6x minus 6. I need to change the signs. So that's going to leave me with a remainder of 5. So 5 is my remainder. So I need to add 5 divided by x plus 1 as my answer, to my answer, okay? And of course that is x cannot equal negative 1. Is it getting more easy now? All right. So now we have part 3 of our objectives in lesson 1, and that is to write the expressions in simplest form using the properties to compare equivalents. And the properties that we're going to use is the commutative property, distributive property, and we also want to make sure we still understand rational expressions. So what do we mean by equivalence? Well, x squared minus 3x minus 40, when it's factored, is x minus 8 times x plus 5. Those are equivalent. They are equal to each other. So that's what we're talking about. Are the terms equal? Are these equal or not? We're going to use factoring to check, rearranging, which is the commutative property, factoring out a negative number, or distributing to check for equivalence. If you want to write that note down, those are the 4 things you want to use to check for equivalence. So let's test those. I've got those coming up on the next slide. Is this equivalent or not? Well, let's use all of the skills. Whoops, go back, hang on one second. Let's use all of those skills that we've learned to simplify our expressions. I know that the top is a difference of squares, right? This is the same as 3 squared. So that can be simplified to x plus 3 times x minus 3. That's my numerator. And the denominator is x minus 3. Is there anything that I could cancel out? Yes, I can. I can cancel out the x minus 3. So that just leaves me with x plus 3. So are the two expressions equivalent? When they're simplified, yes, they are. So yes, these are equivalent expressions. Do you see what I mean by equivalent? If you can simplify this down to this side, they're equal. They are equal. Let's try the next one. Are these equivalent or not? Is there any factoring? Remember we said we've got factoring, rearranging, factor out a negative, and distribution to check for equivalence. Is there any factoring I can do there? No? Well, it looks like the top of the numerator and the denominator are the same, right? This numerator and denominator are the same, but the denominator is the same, but the numerator is a little different. How is it different? And can I make it the same by using a property? Which property am I going to use? I'm going to use the commutative property. Commutative property means I just rearrange. I do them in different order. So I just move those. So x minus 5 is the same as negative 5 plus x. So these are equal. They are the same expressions. Just one has been rearranged with the commutative property. Does that make sense? All right, so let's try this one. Is this equivalent or not? Well, I've got x minus 4 over 4 minus x. So x minus 4 over 4 minus x looks really similar. Let's try the commutative property. Does that help me here? Okay. X minus 4 divided by negative x plus 4. So I just reordered them. Not quite, still not what I'm wanting on the top and the bottom. If I want to equal negative 1, I have to have the same expression over the same expression. Right now, I'm really close there. So what if I factored out a negative 1 on the bottom, a negative 1? So if I take a negative x and divide by negative 1, that gives me positive x. If I give positive 4 divided by a negative 1, that gives me negative 4. Well, I have now got the expression x minus 4 over x minus 4. So that if I cross those off, what does that leave me with? I have 1 in the numerator and a negative 1 in the denominator. The numerator does not become 0. That does not become 0. This becomes a 1. Okay, so make sure you're not leaving it as a 0 or something like that. That's not what happens there. It simplifies down to 1. And then we know that 1 divided by negative 1 is negative 1. So this is equivalent. It just took a little rearranging there and then factoring out the negative. All right, so pause this and I would love for you to check your understanding. This is the end of our lesson here. We want you to make sure that you know how to choose which expressions are equivalent and tell me why they are equivalent. Okay, these are just very similar to what we did on that very first problem. Is 1, 2, and 3, are they all the same expression? Or is just 1 and 2 the same expression? Or is 2 and 3 the same expression? Or is 1 and 3 the same expression? You decide and write your answer down and your reasoning and let us know what you think. If you have any questions, you're going to get more practice in your IXL. So reach out to your teachers if you get stuck while doing those. And I hope you have a great rest of your day.